you ask anyone, if you ask someone total hours in day and night, everyone will say 24 hours. If you say the sum of three angles of a triangle, then everybody will say 80 degrees. So like this, there are many which are constant. They will always remain constant. They do not change. Thank you, best. Thank you very much. So therefore, you should know there are some characteristics which belong to the word variable, and there are some characteristics will belong to the word constant. Now, your variable may be held constant. May be held constant, but a constant cannot be made variable. This is a very important information I am saying. Say, for example, that gender may be held constant. When you say that this college is a girls' college, so boys cannot be admitted. So gender is a constant. This is the science college. That means those students who want to study arts or commerce, they cannot be admitted. So here the subject you have held constant, but subject is a variable because it can be art, science, commerce, technology, etc., etc. If you say that in this webinar, the medium is English, then medium of instruction is held constant. But sometimes if I speak in Hindi as well as in English, then it is not constant because then it is variable. हिंदी में वेरिएबल को चर कहते हैं जो बदल सके. तो देयरफॉर आप जो वेरिएबल है, जो चर है, उसको अगर किसी परिस्थिति में आप उसको कांस्टेंट रखना चाहते हैं, आप उसको स्थिर रखना चाहते तो रख सकते हैं, लेकिन उसकी जो बेसिक नेचर है वो वेरिएबल ही रहेगी. ये आपको पता होना चाहिए. और जो वेरिएबल होते हैं वो हमेशा, डू यू नो हाउ मेनी टाइप्स ऑफ वेरिएबल? हाउ मेनी टाइप्स ऑफ वेरिएबल? बताइए, नाम बताइए. प्रताप जी, प्रताप सिंह जी, नाम बताइए प्लीज. डॉक्टर पानी, आई नो यू नो इट. Lakshmi, your answer is correct. See, variables are always two types. One is called continuous variable and another is called discontinuous or discrete variable. And these are the two types of variable whenever you are conducting qualitative research or quantitative research, whenever you are conducting the philosophical research or historical research or correlational research or experimental research or case study research. Everywhere, these two types of variable are there. In science, by chance, if there are some participants from science, in science, there is one more variable that is called a complex variable. But since in humanities and social science, there is no variable like a complex variable, so we don't use that. But in mathematics, in physics, we do use a complex variable which is denoted by iota. Anyway, I will not do that. So the continuous variables are those which can be expressed in whole number as well as fraction. And discrete or discontinuous variable are those which can be expressed only in whole number. If I give you the example of the continuous variable, then your continuous variable is your weight, your height, your temperature, your achievement in any subject achievement, your intelligence, your reasoning, your power of lens, your hemoglobin, okay, your cost of anything, your length, your speed, your job satisfaction. There are so many variables which can be expressed both in whole number as well as in fraction. And there are many variables. Say here it is intensity of red colors. Okay. And the discontinuous variable, the examples are, say gender, say number of pages in books, say colors, say blood count, say types of car, languages, subjects, types of college, residential background. There are so many variables which are always discontinuous variable. Say marital status, say family size, etc. say your educational qualification. There are so many variables which are discrete variable. You cannot convert them into the continuous variable. It is not possible. Then next here, no weight. Somebody weight may be 45 kg, somebody weight may be 45.5 kg, somebody weight may be 45.75 kg. So it weight can be in fraction. Height, somebody height can be 5 feet, somebody height can be 5 feet 4 inches. So it can be in fraction. So both weight and height can be in fraction, so they are discrete. No, but if it can, that is all right. Your weight is 40 kg, but somebody else weight is 40.1 kg. So you can't say because somebody weight is 40 kg, it is continuous. No. Okay. So therefore, just by saying one particular value, you can't. You have to see the value in a large, a sample. So therefore, the values can be in fraction as well as in whole number. And that is what I wrote. Now, your continuous variable may be changed to discontinuous but discontinuous variable cannot be made very continuous. But discontinuous variable cannot be changed to continuous. See, if you have your weight, on the basis of weight, I can say that you are overweight, over, average, and low. When I'm categorizing the weight in these three, then I am converting a continuous variable into discrete variable or into discontinuous variable. But this is not a permanent change. This is a temporary change. If you have achievement, on the basis of achievement, when you say the student has passed or failed, so pass and fail are the two part of, and therefore you are now making a continuous variable into discontinuous, and these are the two groups or two parts. Or another can be that you may say the first division, second division, third division, and you can say fail. So these are the four categories in which I can divide the people. So although achievement is a continuous variable, but if I like, I can change it to discontinuous. So these are the two types of variable which will be everywhere. Then another is that only in experimental study, only in experimental research, the variables are, one is called independent variable, and another is called dependent variable. Say, if I tell you the quality of food and your health. The changes in your health will depend on the quality of food. So quality of food will become an independent variable and the health will become a dependent variable, because the changes in the health can be brought by changing the quality of food. Now, if it is monthly income and then the quality of food, now as the monthly income improves, the quality of food can also improve. So monthly income is independent and quality of food becomes your dependent variable. Now, in the first example, the quality of food is an independent variable, and in the second example, quality of food is a dependent variable. What is the meaning? The meaning is no variable is forever dependent or independent. It is up to the situation. In the situation, you have to decide which variable is dependent and which variable is independent. I'll take one example from daily life. My dear friend, when you were small, then you dependent for everything on your parents. So your parents were independent and you were dependent. But after some time, when you start earning and your parents, they retire, they become old, then your parents once upon a time were independent, and after a particular age, a particular time, they become dependent. So the parents were independent and now they are dependent at some point of time. Now you were dependent at some point of time and now you are independent at some other point of time. Today you are independent, but do not bother. Tomorrow you will be dependent, because when you become old, then you become dependent. So dependent and independent are not absolute, they are relative. Now, right now, when I am teaching, so I am independent and you are dependent. Now, whatever the method I am using, if you say methods of teaching and you are understanding, so the understanding will change when the methods of teaching will change. So change in the understanding can be brought by changing the methods of teaching. So it becomes an independent variable and this becomes a dependent variable. But you know, your understanding does not entirely change because of the methods of teaching. It may change because of your previous understanding. It may change because of your concentration. It may change because of your study habit. It may change because your interest, etc., etc. So the change in the understanding may be because of the methods of teaching, and it may also be because of previous understanding, your concentration, your study habit and interest, etc. So these variables are called intervening variables. So in the experimental study, there will be intervening variables. And intervening variables are those which are in the process and outside the process, but bring change in the dependent variable in the presence of independent variable. That is what is the intervening variable. Now, right now, wherever you are sitting, if you are uncomfortable, then quite possible your concentration may change for a time. So this is the intervening variable and which is in the process. Suppose wherever you are sitting and you are listening to me, if there are children playing around you, then sometime you might miss some of my statements. So you missed because the children were playing, and because of the outside noise, you could not get my statement clearly. So that was an intervening variable which is outside the process. It's not inside the process. So your intervening variable might be in the process, which is called intrinsic intervening variable, which is inside the process, and another is called extrinsic intervening variable, which is outside the process. And extrinsic intervening variable is also called confounding variable. Okay, there is one more type of a variable which is called concomitant variable. Say, for example, when you are listening to me, I'm sure you are not understanding according to your height. But all participants are not with the same height. So height is a variable which is in the process, but it is not bringing change in the dependent variable. See the color of your dress, you are not understanding according to the color of your dress. So color of your dress is in the process, but it is not going to bring change in the dependent variable in the presence of independent variable. So it is a concomitant variable. Your height is a concomitant variable, but in basketball, your height will become an intervening variable. So in one situation, one variable might be concomitant, but in another situation, it might be intervening. So concomitant variables are those which are in the process, but do not bring change in the dependent variable in the presence of independent variable. And my dear friend, your intervening, your independent variable, as I said, that methods of teaching. So it is a discontinuous variable So independent variable will always be discontinuous variable, and your dependent variable is always continuous variable. And your intervening variable is both continuous as well as discontinuous. Okay, and your concomitant variable will also be the continuous as well as discontinuous. So this is the relationship between the continuous variable, discontinuous, and independent, dependent, intervening, and concomitant variable. So now when we think of analyzing the data, so we will be having the variable which will be the continuous variable, or it might be the discontinuous variable. So these are the two words which I will be using time and again. I'll say this is my continuous variable and this is my discrete variable. And you have seen even in the experimental design, your treatment is always a discontinuous variable and your dependent variable is always a continuous variable. Now, my dear friend, when you are having the variable and you are having the information about the variable, this particular information will be on different scales. So we call it a scales of measurement. Because any variable you have, the variable will have some information. So these informations have been classified under the different scales. We call it a scales of measurement. And some of you must be knowing these scales, but quickly I tell you. One is called nominal scale. Nominal scale means when you get information by counting. Counts. If I say how many people are attending this particular program, then I will say there are 59 people who are attending the program. So when I say 59, then I have counted 1, 2, 3, 4, so 59. When you say number of the books in the library, you will count. When you say how many types of car, you will count. How many family members you will count. How many males in this particular school you will count. So therefore, lot of information will be by counting, or it can be called frequency. So whenever you get the information by counting, then Narayan, you please just wait, because all these I have explained in my earlier classes. So you just wait, I'll find time and will try to help you out. Your all intervening variables are nothing but mediating variables. And moderating variables are those which sometimes you can keep them as one type of variable, or sometimes you keep them as another type of variable. So they are, say, you can say intelligence. Intelligence can be moderating variable. So it depends upon. So here you have the counts or frequency. If you have that, then you can calculate percentages. Then you can analyze your data with the help of chi-square test. You can analyze your data with median test. So there are many statistical techniques which requires the data to be on the nominal scale. Then higher than this is called ordinal scale. And ordinal scale means now you know order, or you can say sequence, or you can say rank. Now you know that in this reality show, what do they say? This participant is first, this participant is second, this is third. They are giving the ranks. The three judges are there, and each judge is giving one's own rank. Now, if I give you 10 handwritings and ask you to arrange it in a particular sequence, then naturally you will see the handwriting and you will fix the criteria which you will use in order to decide the sequence. If the same handwriting I give it to another person, then he may not have the same sequence which you had. He may have some other sequence. So therefore, when you are sequencing, then that means you are ordering, you are giving a rank to it. You know, when you go to any hotel to take your lunch or dinner, then you say, I prefer this. And when you say, I prefer this vegetable, that means that's your first preference. Somebody may say, no, I don't like this particular, so that's fine. Because it is the preference you are asking. So when you have your data on the ordinal scale, then you can say rank preference method of correlation. This is the method which requires the ranks. So you can assign rank. Then another is Mann-Whitney. Mann-Whitney U-test. It requires the rank. So your statistical technique, when you are deciding according to the scale of measurement, you have to decide. So one point in deciding the statistical technique is the scale of measurement. And then there are other points also. I will tell you, okay, for each statistical technique, there are some assumptions which the statisticians had when they started working on that. So I will be telling you the assumptions. And if your data do not follow those assumptions, then you cannot analyze that data with the help of that statistical technique. And one of the assumptions always will be the scale of measurement. Now, the higher, so ordinal scale is higher than the nominal scale. It is quite possible that there might be more than one handwriting which might be on the same rank. So your ordinal scale data can be converted into the nominal scale data. You can say this handwriting and this handwriting both are same. That means two handwritings are of the same type or same, whatever the characteristics. So your ordinal scale data can always be converted into the nominal scale. Then higher than ordinal scale is interval scale. As the name says, interval, that means there has to be a reference point. Or you can say non-fixed 0 point. For example, when you are taking the length of any object, your laptop, then you can take the scale, and on the scale there is a 0 point. Do you always start from 0, or can you start from 1, or can you start from 4? What do you think? Do you always start measuring the length by using the scale, by putting it on 0, or you start from any point? No, Ritu. You can start from any point you like. You need not to start from the 0. If you are starting from 2, then 2 will become 0. And from 2 to 3 is 1, and 3 to 4 is 2, and 4 to 5 is 3. So therefore, in this scale, your 0 point is not fixed. Now, when you are taking your weight, should you have the point, that needle, always in the 0? The answer is no. If it is at 5, then whatever is the reading, you can minus 5, and that becomes your 1. So there, the reference point or 0 point is not fixed, but the intervals are of equal length. That when you say 0 to 1, 1 to 2, 2 to 3, 3 to 4, this difference will always be the same. And when you have your data on the interval scale, then your data is strong. But when your data are either on the nominal scale or on the ordinal scale, then your data are weak data. Now then there is another one. See, when you say the student has got 0 marks, what is the meaning? The meaning is not, please listen, the meaning is not that he doesn't know everything. The meaning is that whatever question was asked, he could not give the answer, correct answer. So that means he does not have that information. That's all. You cannot say 0. No student can get 0. When he is getting 0 in the examination, so this 0 only indicates that this student could not answer the question which were asked. That means the student did not know the information, whatever was asked. You cannot say that he does not know anything in the subject. No, you can't say that. So in achievement, you cannot say absolute 0. There is no. Reasoning, you cannot say there is a 0 reasoning. No. There cannot be zero reasoning. If you have a human being, there must be some reasoning ability. When you are a human being, there will be some degree of stress. You can't say that the stress is zero. No, there is no person with zero stress. There will be some stress. Say reading comprehension. You cannot say there is a zero reading comprehension. Absolutely no. There will be some reading comprehension. It is not if I give you a passage, you may not understand 100% of it, but some percentage you will understand. So therefore, then your data of these variables, whatever the name I have given, is on interval scale. Another is a ratio scale. Now, on the basis of the interval scale data, you can arrange in the sequence, say achievement, is the data on the interval scale. On the basis of achievement, you can arrange it in a particular sequence. So you can convert interval scale data into ordinal scale data. And ordinal scale data can be further converted into the nominal scale data. Okay. And then next is your ratio scale. In the ratio scale, there is a fixed zero. Fixed 0 point. Or you can say there is a fixed reference point. For example, the day a child is born, his age starts from that particular day. For that particular child, the reference point is fixed forever. If you do not have a fixed reference point in the age, then no one will retire. No one will become adult. Everyone will say, I am a child still. So in case of age, it is your fixed reference point. So your data on the age will always be on the ratio scale. And then another is ratios are equal. That makes 1, 2, 4, 8. 1, 2, 1 by 2, 2 by 4, 1, again 1 by 2, 4 by 8, again 1 by 2, etc., etc. So you have your mostly the science data and medical science data mostly will be on the ratio scale. But in education, in social science, mostly your data will be on the interval scale. Now, whenever your data are on the interval scale or ratio scale, this one data is called the strong data. But whenever your data are either on the nominal scale or ordinal scale, these are called weak data. So therefore, depending upon the scale of measurement, you will be deciding which statistical technique to use. Okay. And these statistical techniques have been broadly classified under the two categories. Here I will tell you the base, and one is called parametric statistics, and another is called non-parametric statistics. The difference I am going to tell you now.
Okay.
One difference is the normal distribution. You know the normal distribution, that there are different types of distribution. I'm sure you must be knowing. One is exponential distribution, regular distribution, U distribution, normal distribution, chi-square distribution, Poisson distribution. So there are different types of distribution. So you will use the parametric statistic when it is normal distribution. And you will use the non-parametric distribution when it is any distribution. So since there is no restriction on the distribution, so another name of the non-parametric statistic is distribution-free statistics. So your non-parametric statistics is also called distribution-free statistics. That means there is no restriction, there is no condition of the normality. It can be any distribution. Then another is a scale of measurement. The parametric statistics can be used when your scale of measurement is interval scale or ratio scale. If you have a nominal scale, you can't use parametric statistics. If you have the ordinal scale, you can't use parametric statistics. You have to use only parametric statistics when your data are either on the interval scale or ratio scale. But if it is non-parametric statistics, your data can be on any scale of measurement. Your scale of measurement can be nominal, can be ordinal, can be interval, and can be ratio. If your distribution is not normal and your data are on the interval scale, then you cannot use the parametric statistic, then you have to use the non-parametric statistics. Then another is called the power of statistics. Power of statistics. Your parametric statistics are more powerful. And your non-parametric statistics are less powerful. What the meaning of a power? Power means if a hypothesis, a null hypothesis is to be rejected. I repeat, if the null hypothesis is to be rejected and your statistical technique helps you to reject it, then your statistical technique is powerful. If your null hypothesis is not to be rejected, and your statistical technique helps you not to reject it, then also your statistical technique is powerful. But if your statistical technique does not help in rejecting the hypothesis when it should be rejected, then it means your statistical technique is weak. So that is what exactly is the meaning of that. Now, let me tell you some examples of the statistical technique. That parametric statistics, there is something called t-test, or its another name is independent samples t-test. Please do not use the word sample. It is independent samples t-test. Or another name is students t-test. These are the three names of the t-test. I don't know whether you know all these names or you do not know. When you want to analyze your data with the help of non-parametric statistics, you can use test, you can use scale, you can use inventory, no problem at all. You can do that. No, non-parametric. Please understand now, if your distribution is not normal and you have your scale of measurement interval scale, then you cannot use the parametric statistics. You have to use the non-parametric statistics. Parametric statistics you will use when your distribution is normal and your scale of measurement is either interval or ratio. So if these two conditions are not satisfied, then you cannot use the parametric statistics. You have to use the non-parametric statistics. Then another statistical technique is called one-way ANOVA. Then it is also called the two-way ANOVA. Then there is also called three-way ANOVA. Then it is also called one-way ANCOVA. And another will be two-way ANCOVA. Another can be three-way ANCOVA. Another is correlation. Another is partial correlation. Another is multiple correlation. Another is regression analysis. Another is factor analysis. Another is discriminant analysis. Like this, there are many parametric statistics like this. Then non-parametric statistics are your chi-square, then your Mann-Whitney U-test, then Friedman analysis of variance, then your sign test, your median test, like this. There are so many tests which you can use only and only when your condition of normality is not satisfied and your data are not on the interval scale and ratio scale. When your data are weak data, then you can use it. Okay. So therefore, I have given you the basics. I have given you the variables, type of the variables, and I have given you the statistical. Now, tomorrow, when I start, then I will be taking the variable. I will write the title. I will write the objective. I will write the hypothesis. Then I will take the data and use SPSS, analyze the data, and tell you how to write the interpretation of that. And my humble submission to you is, please try to read the concept of degree of freedom and level of significance. Please try to understand these two concepts because I will be using these two concepts tomorrow. So thank you very much for joining this particular program, and those participants who have not officially registered, my humble request is, if you like my teaching and if you think that this webinar will help you in improving your research competency, please register yourself and then you are welcome to attend the program. So thank you and thank you very much. See you tomorrow at 6 o'clock. Thank you. So nice of you.